There's been some recent research to suggest that upside down snow might have formed Europa's icy crust, which sounds really strange. So we're going to have a look at what that means in the context of forming the icy crust and a quick introduction to Europa, which is a moon of Jupiter. So Europa is one of Jupiter's Galilean moons. There are 4 of them, and Europa is one of the best locations in our solar system to potentially look for life, and it might harbour life. We don't know, but it's the best place we might want to go and visit. The other one is Enceladus around Saturn. They're quite similar in that they have a frozen icy surface and then liquid oceans underneath. So just an illustration really of what this might look like. So we have this frozen icy crust. There are some plumes that come out, and you have a water ocean underneath, which are thought to be kind of heated by like thermal vents and that down below. So you've got this water ocean underneath, which is the right sort of temperature possibly to support life, and you have this icy crust. But how does that icy crust actually form? So this research suggests that it's upside down snow. So it's not really snow because you're in a water ocean, but it's ice that's going to be drifting upwards onto the actual icy crust from underneath. But this research suggests that's how this crust might actually have formed. So on Earth, there's a few ways in which you can grow these ice sheets. So one of them is from the ice shelf surface itself. So the ice surface grows essentially on the surface like that, and that's one way that it can grow. And then the other way is this Frazzle Ice, which forms and then drifts upwards as flakes then get trapped underneath the ice sheet. If you have this ice sheet already there, formed from the other process, you then have this other formation process where you've got these kind of fluffy flakes floating upwards that then get stuck underneath the ice sheet. Now, the thing here is that this particular type of ice is almost pure water ice, so it has very little salt content in it really. So it doesn't have high salt content, and it's much lower than the rest of the ice sheet, which is important for understanding the composition of not only the ocean but the ice sheet itself. So it has a very much lower salt content than what would form the ice sheet normally. And this particular type of ice forms when you have a very small temperature gradient in the ocean. And this actually occurs in Antarctica as well, has a very shallow temperature gradient. What does that mean? Well, it means that if you go deeper into the ocean, that the temperature doesn't change that much. So there's not much of a temperature gradient. And the same is thought to be there in Europa, which then facilitates this particular type of ice forming. Now, compared to what we thought about the crust or the icy sheets on Europa before, they're expected now to be less salty than we first thought they might be. Because this particular type of ice is forming the crust, it's going to have much less salt content because it's almost pure water ice as opposed to having some salt in there. So this has consequences for the actual composition of the ice sheets. And why do we care about that? Well, the composition and the salinity are important for things like habitability. If this is one of the best places to go and look for life, which hopefully in the future we're going to send some spacecraft there, some probes, and maybe actually have a look in the ocean. But understanding the composition and like the salt content there is very important to consider whether it is actually suitable for life or not. And it's just good to understand basically. So we need to look into that. So thank you for watching, and if you enjoy, then check out some of the other videos.